Hi all, this is Pawan Kumar Sharma and I am a physics faculty working for Narayana Group, and here I am discussing physics question paper, mains paper, which was conducted on 30 Jan morning session. Remember, these questions are majorly memory based, whatever the information given to us by the students who have written exam on that particular slot. So the actual questions and these questions may vary slightly in reality. And here comes the first question. Here is your first question. Two rings of equal radius are arranged mutually perpendicular to each other with common center C carrying equal current I. Fortunately, this is, see, if it is one coil, field at the center is equal to B is mu naught I by 2 times the radius R. Both the magnitudes are same and both are mutually perpendicular to each other. One is in this direction, the other is in this direction, upwards and rightwards. So therefore, what is the resultant? Resultant is nothing but root 2 times B. So the answer is mu naught I by root 2 R, and my answer is 4, and that's all. This is question number 1. Now, we are moving on to the question number 2. See, try to understand in this particular question, you need to know that there exists. Say, I am assuming this as B and this as A. Now, I am assuming, right, this acceleration is AB and this acceleration is AA. The first thing that you need to obtain here is the constraint relation between these two. So, 2 times acceleration of B is equal to 2 times acceleration of B is equal to 1 time acceleration of A, by which rule? Sigma I Ti Si is equal to 0. So from this you got the relation. Next, now you see B. Now B, remember a free body diagram of B says that 40 minus 2t is 4 times acceleration of B. Right. Remember, they are asking acceleration of 2 kg block. So therefore, this can be written as 2 times acceleration of A. Fine. This is equation 1 for me, and we will move on to the equation 2, which is for the 2 kg block, free body diagram of 2 kg block. So therefore, T minus 20, in some books it was given 30 degrees. In some books in the sense, some informations, some students who shared the information, they have given 30 degrees. Some students given 37. Oh, whatever it is, concept is the same. 20 into sine 37, G sine 37. Sine 37 is 3 by 5, is obviously 2 times acceleration of A. That's it. You have two equations. Just solve it. You will get 2t minus, this is 5, 4, 12, 24 is 4 times acceleration of A. This is a modified form of equation 2. By just adding both, you will get the desired answer. Right? These are the two equations, and the first thing is constraint equation. Next question. Third question. And remember, it's a very simple question. Only thing that you need to know is the basic concept involved in this. This is your projectile path, right? Parabolic path. At this point, you are asking the point, find its angular momentum about the point of projection when it reaches the maximum height. By the way, the momentum here is mu cos 30, and this is the maximum height h. So about this point, area mv perpendicular distance. So therefore, mu cos 30 perpendicular distance is nothing but maximum height. So m root 3 u by 2. What is maximum height formula? U square sine square theta by g. So u square sine square theta means 1 by 4. U square sine square theta by 2g. 2 into g. So root 3 and denominator should contain 16. The only possible option for 3 is the second option. Right? That's it. It's an easy question according to me. Next, fourth question. ratio of kinetic energy and potential energy in the fifth excited state of hydrogen area circular orbit, whatever you take all the time, Ke is to Pe is to total energy, bear a fixed ratio. This is only for circular orbits. 1 is to, minus 2 is to, minus 1. So what do you want? Ke is to Pe ratio. That is one, option 3, right? Next. The fifth question which you have is, in the given circuit, find the potential difference across the 700 ohm. See, try to understand in this circuit, this part put together, the entire part put together is nearly 3.7. In some question papers, it was given as 3.2 also. In some question papers, it was given as 3.2. So, whatever it is, concept 3.7 ohm or 3700 ohm. 3700 ohm is the resistance of that part, and this part is 700 ohm, right? Find the potential difference across 700 ohm. It is like 337 1000 is to 700. So 37 is to 7 is the ratio of resistances. So you need to break 7 volts accordingly, like that. So by doing which you will get, see, probably 0 is not the answer. I am very sure about that. Suppose if this is 35 instead of 37, actually in some books it was given, in some papers, in some students information it was given as 3.3, not 3.5. So I am assuming that is correct. Suppose if that is correct, then that will be 35 is to 7, which is nothing but 5 is to 1. 5 is to 1. Now, if it is a 5 is to 1, the contribution part here is 1 by 6th of 7, slightly above 1. Only one option possible. Right. I still believe it is 3.2. Maybe some other students would have given 3.5, but this is very comfortable for me. Right. Next question. You have a ball is released from a height of 1 meter on a smooth hemispherical surface as shown. Find the velocity when it is at a height of 0.5. Law of conservation of energy. That's it. See, by the time when it is at a height of 0.5 meters, loss in potential energy is mg, height 1 and 0.5. So 0.5, that is a half mv square. So v is laterally root g, root 10 meter per second. So answer is 3. That's it. Next, find the current through the GNR diode if the breakdown voltage is 5 volt. How can 29th morning, almost same question. Even now, you have the same question. Literally, the same question gets repeated. I don't know how many times this gets repeated in your papers also. Find the current through GNR diode if its breakdown voltage is 5 volts. Remember, what is the ratio here? 2 is to 3. So, you are breaking 20 into 2 is to 3. Means more than 10 volts across 30 ohm. I repeat, more than 10 volts. So diode is in action. So what is the drop across 300? Obviously this is 5 volt. 5 volt is the drop across this. Then what is the drop across this? 15 volts. Now please try to understand what is the main current. 15 volt by 200. So this is nearly 75 milliamps. That is the 75 milliamps. And the other part is 5 volts by 300. Now, if you make it 50 by 3000, nearly. See, I am telling you this is a 50. So, 50 by 3. This is slightly more than how much? 3 bonds, 3 15s, 45, 3 16s, 48. So this is nearly 16 milliamps. Remember, I am roughly doing this. So 75 minus 16. So therefore, obviously, none of these questions will manage with the answer range. 75 milli minus nearly 16 milli. So obviously, the answer fetches to first question. See, I assumed this as 550 by 3 milli as nearly 16 milliamps. Next. That is how you are supposed to do in exam. You have big variation in the answers. Then why should you do till the last time? Next. Eighth question. Ball released from a height 10 meters, strike the ground and rebound to a height 5 meters. Means if it strikes with root 2 GH1. Bounce back to a height H2 means 8 root 2 GH2. Now, earlier, change in momentum means mass times root 2 GH1 plus root 2 GH2. Why are plus? Because directions are different. So, therefore, by properly solving this mass 100 grams, so 1/10, and in the root, in the first part 10, this is 10. Already this is 20. So, root 200 plus half of this root 100. Obviously this is root 2 plus 1. So, my answer for 8th question undoubtedly 4. Right. Next. Potential due to an electric dipole on the axial position are repeated number of times this question arrived even in the last 4 or 5 examinations, 5 sessions I mean. So potential is P by 4 pi epsilon naught R square. Remember this is for dipole. So therefore ninth question, what is the proper answer? 3. Next, maximum wavelength of light source such that the photoelectron can be ejected from a metal or work function 3 electron volt is area. They are asking you threshold wavelength. Area, whatever it is, my standard presentation 12,400 by 3. Now tell me what is your answer? 3. Simple. Remember, when you are writing this, you will get the answer in angstroms. Next, easy question. You should be very happy for such a question. A long wire carrying current root 2 amps is placed in a uniform magnetic field. Remember, if the magnetic field is perpendicular to the wire, whatever it is, find the magnetic force on the unit length of the wire. F is BIL, total force, and you are asking per unit length. So, per unit length, right, per unit length means I don't require even F by L. This is BI means 3 into 10 power minus 5 into root 2. Here, 11th question, only one option. Very comfortable. Suppose if the field is like this and a conductor is like this, in this case force is 0. So this is perfect condition for us, mutually perpendicular BIL. Next, area of cross section is hard, length of the wire having Young's modulus Y is double, then its Young's modulus will become a, come on. It's a steel wire after all. For example, you make it half, you make it double, in spite it's a steel wire. Material though, it's the same. It is the same material, by the way. So Young's modulus remains the same, and I should write this as Y simply. Next, in an electric transformer, you have a situation 220 volts is applied on primary coil. Transformer question is repeating a lot of times. Just please take care of this. And it is having 100 turns. Find output current through 3 ohm resistance. If the number of secondary terms is the area V primary by V secondary is N primary by N secondary. That's the deal. So therefore, V primary 220 volts by V secondary. Take this number of turns 100 and 10. So therefore, V secondary is 22 volt. In some questions given by students, I was told that they just asking Vs. But in this, there is an extension, no issues. Now, what do you want? Find the output current to 3 ohms. So the current is obviously 22 by 5. So what is this going to be? Nearly. So 22 by 5 is a nearly 4.4 amps. So therefore, my answer is 2. Next, Find the temperature of the hydrogen gas at which its RMS speed is equal to that of oxygen at 47 degrees centigrade. Remember, 47 degrees centigrade is to be converted into kelvins, and that will become 320 Kelvin. Right. What is that you are saying is RMS speeds are equal. VRMS is, what is VRMS? Root 3 RT by capital M. So, if by equating which you will get, in fact, you are equating T by M, otherwise 320 by 320 by RMS speed is equal to that of oxygen at 47 degrees. 32 is T by, in fact, 2, hydrogen and 2. So obviously, this one also different inputs I got. Actually, 47 degrees is given for hydrogen. Likewise, people told, but as I mentioned, this is a memory based question paper. So obviously, T becomes 20 Kelvin, but no answer 20 Kelvin. So you should convert it into centigrade. So therefore, you should add minus 273 plus 20, and that will become minus 253. So the answer is minus 253 degrees centigrade. Right. Come on, next question. AC circuit with source voltage given. Omega is 1000 in this. It's a LR circuit basically. Power factor is 1 by root 2. Remember, if it is mentioned as 1 by root 2 means, power factor if mentioned as 1 by root 2 means, this angle will be 45. Means omega L is equal to R. On the basis of the first part of the data. Now, you have doubled omega. What is the new power factor? If I have doubled omega, this will become 2R. And this will become R. This is for the case where omega is equal to 1000. This is the case where omega is equal to 2000. So obviously what will happen? Power factor phi. Cos phi is 1 by root 5. So my answer is 2 for this. Remember, what is that you need to understand is, you should use the data of the first part and the second part of the question. Next. In an electromagnetic wave, the electric field is given as, what is that you understood from omega t minus kz? Means, if I am not mistaken, the wave is propagating along, wave propagation is along k cap. And electric field vector is along I cap. And you already know E cap cross B cap. Right. So therefore, k cap is I cap cross j cap. So therefore, all are in, only two are in j cap. And one more important point is B naught is E naught by C. So therefore, the final equation is B E naught by C sine omega t minus kz, and it is j cap. So therefore, 16th question, the correct answer will be 2. This one. Almost that question was repeated a lot of times. At a point away from the planet of radius 6400 kilometer, the gravitational potential and field were given as SI units. Find the height of that point above the surface of the planet. Hold on. Now see, what is gravitational potential? Gm by R plus H is given as 6.4 into 10 power 7. And one more important point, field Gm by R plus H square is a 6.4. Now please tell me what you would like to conclude from this particular data. Find the height at that point. What if I go for a ratio? If I go for the ratio, what I am going to get is R plus H. So R plus H is literally 10 to the power of 7 meter. Right. Find the height of that point above the surface of the planet. See, radius is 6400 kilometer. 10 power 3 plus h is 10,000 times 10 power 3. So the difference is what you need to take, and the difference will become 3,600 kilometers. Easy. Almost 29th morning, also a similar kind of question came. Maybe language is different, data is different, but concept is the same. 18th question, what is that you have is wire of resistance 60 ohm at 27. Remember, don't use 27 degrees as the criteria, you should convert into kelvins. So which means in the first part of the data you have 60 is some R0 times 1 plus alpha times 27, you please convert, this is 300 Kelvin. Similarly, 220 volts by 2.75 is 80. So 80 ohms is R0 times 1 plus alpha T. Now you have two equations. Alpha is also given. Go for the ratio, by doing which you will get the answer as 1. Just go for the ratio of these two things. Alpha is also given for you, remember. Next, 19th question is a very easy question. Units and dimension based matrix match. The angular momentum. The angular momentum, MVR, right? So what is the dimensions for this? MVR dimensions M L square T power minus 1. So R2, only one case is there. Let me check the other. Rotational KE, whether it is a KE or rotational KE makes no difference. So energy, ML square T power minus 2. Yes, one. Only one option. This is the option. And why should I do the other? Next. A block of mass 2 kg is placed on a disc which is rotating with a constant angular velocity 4 radians per second. Find the frictional force between the block and the disc, and the block is not sliding. Remember, that's a very important statement. Why? See, what supplies the necessary centripetal force? Otherwise, it is the friction that supplies the necessary centripetal force, which means this is mr omega square. 2 kg radius is to be given. Actually, it was not given. R omega square 4 square. So in this particular question, actually, when this question was given, I think I am still very clear on the data given by the student. I just want to post one data added to this. Radius is 1 meter, already given in the diagram. So therefore, that's fine. A radius part is given. So we will proceed further. 2 into 1 into 4 square. And what is going to be this? 32 Newton. Right. Easy question. See, I just want to post another. Almost every session there is a question from horizontal circle. Distance between virtual image, which is twice of the size of the image, placed in front of almost the same question, almost a very similar model repeated, which is of twice of the size of the object placed in front of the mirror, and object is 45 centimeters. Magnitude of the focal length of the mirror is, you said magnitude of the magnification is +2. Means this is a concave mirror, for example. Real object U, and 2U is the position of the image. So what is that you know is 3U is 45, U is 15 centimeter. Done. What is that you need is 1 by V plus 1 by U is 1 by F. Remember, real image 1 by 30 plus real virtual image 1 by 30 plus 1 by minus 15, right? That is equivalent to 1 by F. So by simply solving, you will get the value of F as 30 centimeters. So 30 centimeters is going to be your answer, right? See, just don't care. You may get F minus 30. Concave mirror, negative. You should post 30 only because magnitude is what they have mentioned. So you should post the 30 only. Don't post minus 30 there. So a particle is having uniform acceleration. Its displacement. What is that mentioned there? From t to t plus 1 seconds is 120 meter. T to t plus 1, right? S t plus 1 is simply ut u 1 minute u plus half into, here I'm not using a different formula, you know this, u plus 2n minus 1 a by 2. I'm using the same. In the place of n, I'll post t plus 1. So therefore 2t plus 1 into a, right? And s t plus 2 is u plus half 2t, right? In the place of n, you are posting now 2t plus 2, remember. So that will become 3a. And one more important point, what is this 50? Acceleration is given to you 50 by 1, 50 meter per second square. Now you have the data, find the displacement in t plus 2 seconds is what they are asking. I'll simply substitute. I have two equations, by the way. This equation uh, gives me 120, and this equation I literally have a, and I'll simply substitute this. So I'll get the answer, or else let this be equation 1, let this be equation 2. 2 minus 1 gives me the answer, and I'll get the answer as st plus 2 minus st plus 1 is simply a, if I'm not mistaken. So obviously that part is 50, and this part uh, that part is 50, and this part is 20, and st plus 2 is 120 plus 50, and that is 170 meters. If I'm not mistaken, please don't mind. If I'm not mistaken, 8th, 9th class student can comfortably do this question. So such an easy question is this. Uniform disk of mass 5 kg, radius 2 meters, is rotating with 10 radians per second. Now another identical disk is gently placed on the first disk. First of all, what is the moment of inertia of this system? Disk mr square by 2, 5 into 2 square by 2. This is nearly 10 kg meter square. Both the disk attain common angular velocity, loss of kinetic energy. If it is point masses, you would have written half m1 m2 by m1 plus m2 u relative square. Since it is rotation, half I1 I2 by I1 plus I2 omega relative square is simply omega square here. Half into 10 into 10 by 20 times omega given as 10 square. So solving which you will get 24th question, the answer as 250 is all. Remember, this is the last part, right? Next, 25. You can see two cells, all are in series. Obviously, this is the driving cell. This is the driving cell. So now what happens? Now what is the current in this? Net EMF 8 minus 2 by total resistance 6, 1 amp. What do you want? Find the potential difference across AC. If I am not mistaken, it is across AC. If it is across AC, I don't need to find. Actually, I heard this different ways. Some student told me across 2 volts battery. Some students told me across 8 volt battery. If it is across AC 0, it's a conductor basically. So I say 0. If it is across BC, obviously I would have written minus 2. I mean VB minus VC. I would have written minus 2 plus 1 into 4, which is plus 2 volt. 25th question, easy question. Next, Electron in a hydrogen atom is excited to an energy level having energy 0.85. Have you identified what is that quantum state? N is equal to 4. That is corresponding to N is equal to 4. I don't know, sir. No issues. Minus 13.6 by N square is equal to minus 0.85. Do this, you will get N as 4. Find the number of possible transition it can make with the de-excitation. N into N minus 1 by 2. See, remember a collection of hydrogen atom, if you have literally 4 into 3 by 2. So 6 possible lines, 6 different lines are noticed in the uh, spectrum, emission spectrum. Right. 26th is a very easy question. Right. Next. The last question, if I'm not mistaken, it's a last question, and that question is energy stored in circuit 1 is E, right? Where the energy be stored? Stored in capacitor otherwise, and that part is half CV square, and that is given as E, right? If in this particular circuit, what was mentioned? If capacitor in circuit 1 and 2 are interconnected, this one stores an energy half into 2C into 4V square. So this is 8 times of E. Save it. Now what do you want? When they are connected like this, like plates are connected, we know the formula. Half, are like previously M1 M2 by M1 plus M2 V relative square. Half I1 I2 by I1 plus I2 omega relative square. Now C1 C2 by C1 plus C2 into, remember, like plates same side, V1 minus V2 whole square. So half C into C by C into 2C by 3C times first one potential difference V, the other one potential difference 2V, difference is V square. So hold on, the core part in this what you need to understand is half CV square times 2 by 3. So therefore CV square by 2 is nothing but E. So therefore my answer for this particular question is 2 by 3 E. I repeat, 2 by 3 E. What is that? They are not asking last year. They are asking, as shown, the energy stored becomes XE by C. This is the loss. Now, what was the total energy you have? 9E totally. Now, what is the loss? 2 by 3E, right? Best please check if you have any doubt. Right. 9E minus 2 by 3E is the energy finally available, which is 25 by 3E. This entire thing is 25 by 3E. They are asking this as XE by 6, 2 times. So X is 50. A very clever way of solving this question is identifying this particular relation. Otherwise, it's a bit lengthy question which takes a lot of time for you. Remember this question and the previous this question. I'll just display that. Even this question, logic is the same. Next, right? If BC has Young's modulus so and so and cross sectional area so and so, find the strain in the wire BC. Can I find the tension in that? Yes, it is possible for me. How? I'll take this entire thing as one system, this entire thing as one system. So acceleration is 3g by total mass 9, z by 3 meter per second square. So again, I heard this differently, different way, different questions. Now, by the way, tension is 6 times the acceleration of the system. 6 into z by 3, 2 times 2g, 20 Newton. I have tension now. So I can find elongation. By the way, you are asking strain. By the way, T is equal to YA by L into E. Earlier tension I have, Y I have, A I have, E by L is what expected, T by Ya. That's all. This is the strain. So by doing this, you will get the value approximately nearly almost 20. If you want, you can substitute also. 20 by Young's modulus given is 2 into 10 to the power of 11. Area of cross section is given as 5 into 10 to the power of minus 4 centimeters square. Don't forget, you need to convert that into meters square. So that's the deal. They are asking strain in the wire BC, right? That's it. So whatever the questions we have collected so far, this is what we have, and we have projected all that onto the screen. And I wish you go through these questions in your future coming examinations. It will be useful for you because repetitions are noticed a lot. And I wish you all the best for your upcoming sessions. Thank you.